This is 11.3, combinations. On this first slide, we get a chance to review permutations. A permutation is an arrangement of items in a particular order. Notice, order matters. When we covered this section on permutations, I asked you to remember different types of scenarios in which we can recognize that we have a permutation, such as racing cars and looking at the first, second, and third place finishers of that race. Order matters. If we are selecting specific offices or officers for a committee, such as the CEO, the manager, the treasurer, those are unique situations of positions. We want to think that order matters. If you're running for the CEO and you end up getting the treasurer position, I would think order matters. Now, for combinations, a combination is an arrangement of items in which order does not matter. For instance, let's say we have a class of 30 students and we want to select 5 students randomly to create a presentation for us. We're selecting randomly. It does not matter which students we select. Order does not matter. All right, this slide shows the formula for calculating the combinations of n things taken r at a time. N things taken r at a time. Before we go over this formula, I want to refresh you on using your Casio calculator. So this instruction is for the Casio 115 ES Plus calculator. And this is going to cover the factorial. And that was n with an exclamation point on there. So to put this into your calculator, you need to type your number in first. Press the shift key. Then the x to the -1. Press that key next. And then your equal. So if you place 3 factorial into your calculator and press equal, your result should be 6. If we're looking at performing the permutation, you type your number in, and this number represents the n, and then we press on shift. Then you press the multiplication button, type in your next number, and this number represents the r, and you press equal. So on your home screen, it should look something like 5p2, and then you can calculate that. Now, with regards to the combinations, it is similar to using the permutations. Instead of the multiplication key, we are going to use the division key. So I'll just make a quick note down here. Type your number. Shift key. Division key. Type the number that represents R. Equal. And this time on your screen, it should look like something with 5C2. All right, so look at this formula. It says it is n factorial over, parentheses n minus r factorial times r factorial. Now, although we're using this formula and you can work everything by hand, we will have a tendency of using our calculator to expedite the calculations. Let's carefully read this word problem. A 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So it didn't specify positions or unique positions of this committee. It just says a 3-person committee. So in this case, order does not matter, and we will be using a combination. So I'm just making a note to self over here so we know what we're doing. So in a combination, we need an N and we need R. So the number of people that we are choosing from are the Board of Supervisors. So we have N equal to 8, and we have a 3-person committee. So R is 3. So we are going to do 8 combination 3. 8 items taken 3 at a time. Now again, you're going to place this in your calculator, following the steps from the previous slide, and you should come up with 56. We're creating committees here. All right, if you want to use the formula, and I'll just do this on a few slides, we have 8 combination 3. That is the same as 8 factorial divided by 8 minus 3 factorial times 3 factorial. Cleaning up what's inside parentheses will leave me with 5 factorial times 3 factorial. And I'll show the handwork on this. For the numerator, I'm going to take this as 8 times 7 times 6 times 5, and I'm going to stop at 5 factorial because I have a 5 factorial in the denominator. And I'll expand the 3 factorial. 3 times 2 times 1. All right, remember this is a multiplication. I'll just put a little multiplication symbol in there. So when we go through and look at this now, what we can do is divide out the 5 factorials. And then we can also take a look at 3 times 2 in the denominator. 3 times 2 is 6. And divide out that 6 in the numerator with the 6 in the denominator. And this will leave you 8 times 7 over 1, or 56. So we came out with the same answer, working by hand and also just by putting it into your calculator. Before we look at the next problem, I want to review a deck of cards. So a deck of cards, a standard deck, has 52 cards. We have a total of 52 cards. If you take a look at this, we'll just look on the suits over here on the far right. We have 4 different suits. We have hearts, clubs, diamonds, spades. 4 different suits. Now, in each suit, we have 13 cards. The 13 cards start here with an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have a jack, queen, and king. The jack, queen, and king are called picture cards or face cards. They have faces on them. All right, so 13 cards in each suit. You have 4 suits: hearts, clubs, diamonds, spades. All total to 52 cards. All right, in poker, a person is dealt 5 cards from a standard 52 card deck. The order in which the 5 cards are received does not matter. So let's slow down right there. Order does not matter. So that's telling you you have a combination to work with. How many different 5-card poker hands are possible? So knowing that we have a combination, we need to identify our N. We have a total of 52 cards. And the R, we're doing 5-card hand, poker hands. All right, so then we'll go in and place this in our calculator. You're going to do 52 combination 5. And you should get, let's see, 2, 5, 9, 8, 9, 6, 0 looks correct. Let me put some commas in here so it makes sense. 2,598,960 possible poker hands. All right, so if we had to set this up by hand, I don't know if I'll show all of it, but I'll certainly get started on it. So 52 combination 5. So I have 52 factorial over 52 minus 5 factorial times 5 factorial. So that will leave me with 52 factorial divided by 7 factorial times 5 factorial. All right, and if you do the longhand on here, we'll have 52 times 51, 50, 49, 48, 47. Again, I'm going to stop at the 47 factorial since I have a 47 factorial in the denominator. Then I'll take that 5 factorial and expand it. 5 times 4 times 3 times 2 times 1. And again, just a little symbol inside so you remember that we are going to multiply. So we can first divide out the 47 factorial, and then I can reduce if I want to. I can take the 50 divided by 5 here. That will give me 10, if you want to look at it like that. And then we can also do the 3. 3 will go into 51. 3 divided by 3 is 1. 51 divided by 3 will give me 17. Just reducing, that's all we're doing. And then we can do the 4 if you want to into the 52, however you want to reduce this, whatever speaks to you. So let's try yellow here. We can do 4 divided into 52, and that'll go 13 times. And let me grab one more color here. Let's get rid of our 2. 2 will divide into 48, 24 times. So if you take a look right now in our denominator, we have a 1. And then we could take all the remaining numbers, the 13 times 17 times 10 times 49 times 24, and we will get the same number. All right. So this is a combination, and I bet right about now you're really enjoying that calculator. All right, let's go on to the next one. All right, so here's our new problem. In December 2011, the U.S. Senate consisted of 51 Democrats, 47 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? So we need to think about this. It looks like we're taking 3 Democrats out of the 51 total Democrats that we have to choose from, and we need 2 Republicans out of the total 47. And we do not need any independents. So let's set this one up. Let me go ahead and put in some colors. 51 Democrats, and we're creating a committee. We need 3 Democrats. The Republicans are 47, and we need 2 of those. All right, so let me just write this up here. For the Democrats, we have 51 choose 3, right? Then we're going to do our Republicans. And that one's going to be, we have 47 Republicans, and we're choosing 2. Right, and I'll put this over here, the independents. There are 2 independents, and we're choosing 0. All right, so you find the combination for each of these, and what you need to do with this is to go in and multiply them. So we're going to take this combination times the Republicans, and you can do the independents. That's just going to be a 1 there. Right, and you put this in your calculator, and your result should be, let's see, 22,511,825 distinct committees. That is a lot of variety in the committees there. All right, so make sure that you're noticing that we have a combination because order does not matter. It just says choose 3 Democrats. So we're going to find that combination. Choose 2 Republicans, and that will satisfy our 5-person committee. And we're going to choose 0 independents. So carefully read and make sure you remember to multiply. All right, this one just says evaluate the expression. So you have 5 combination 2 times 9 combination 1, all divided by 27 combination 3. So the first thing you want to do is hit the fraction notation on the Casio 115ES. The fraction looks like a little box with a division bar and another little box. All right, it'll be highlighting up into the up numerator. And from the numerator, what you can do is you can press 5, the divide, and the 2. All right, and that's going to be times. And the same thing, we're going to do 9, shift, divide symbol, 1. All right, then you're going to use the down arrow so that it brings you down to the denominator. And here you'll place 27, shift, divide symbol, then 3, and then you're going to do your equal sign. All right, and when you do that, you will notice that you're getting a simplified answer as a fraction, 2 divided by 65. All right, and unless the instructions ask you for a decimal notation, you leave it as a simplified fraction or an integer. If it is a decimal notation, it will tell you where to round to. Again, this is for the Casio 115 ES Plus calculator. Let's take a look at these problems. The first one goes, in a race in which 11 automobiles are entered and there are no ties, in how many ways can the first 3 finishers come in? All right, so when we take a look at this, there's a few things that we need to point out. We know that we have 11 automobiles, right? And there are no ties. And it says, in how many ways can the first 3 finishers come in? So in this case, order matters because you have first, second, and third. So I'm going to make a note to myself, order matters. Therefore, that's helping me lean towards a permutation. All right, so in this case, we have a total of 11 automobiles. So my N would be 11. We're looking for the first 3 finishers, so my R is 3. And so from here, we'll set up our permutation. 11 permutate 3. And you can place this into your calculator, and your result should be 990. 990 ways that the first 2 finishers can finish that race. All right. And the one here on the bottom says, how many different 5-letter passwords can be formed from the letters A, B, C, D, E, F, G, and H if no repetition of letters is allowed? All right. So once again here, we have no repetition, which was noted on the very first slide of this session when it said that in permutation, there's no repetition. All right, we have a 5-letter password, and then we have some letters here. All right, so let's take a look at, we know we're going to choose 5-letter passwords, so we're choosing 5 at a time, but we're choosing from how many letters? So let's count these, starting with your A. 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 letters here to choose from. This is your N. And we have a 5-letter password. So R is 5. All right, once again, this is a permutation because order matters, and we have no repetition. So we're going to take 8, permutate 5 at a time, place this in your calculator, and you will create 6,720 ways to create a 5-letter word or password. For this final problem, you want to read carefully and try to remember what we've seen so far. So far, we've seen the fundamental counting principle, permutations, and now we're moving in with combinations. So let's read this carefully. An ice cream store sells 5 drinks in 4 sizes and 3 flavors. In how many ways can a customer order a drink? All right, so we have 5 drinks, 4 sizes, 3 flavors. All right, you need to ask yourself, does the order matter on here, on how you select each category for your drink? The answer is no, there is an order on there, but this is the one you were going to choose the fundamental counting principle, which I called FCP, fundamental counting principle. It's kind of like that example we saw in the previous sections for 11.1 when we talked about the young man that was selecting his outfit with 2 pairs of pants, 3 shirts, and 2 shoes. All right, the different combination of that, or the meals, how many ways can we order a meal using 3 courses or 3 categories? So this is 5 drinks times 4 sizes times 3 flavors. And that will give us 60 ways to order a drink. All right, so read over these carefully. Best thing to do is ask yourself if order matters in this situation. And if the order matters, you want to start thinking of your different examples we've gone through about permutations and the keywords that you want to look for. The no repetition, order does matter, distinct ways. And if it does not matter, you're looking for your combination. This concludes 11.3.